So we are going to talk about open system flow. Open system flow, you know everything, just everything. You can use the P1 by P2 gamma raised to gamma minus 1 upon P1 by P2 raised to gamma minus 1 by gamma is equal to T1 by T2 in turbine, nozzle, diffuser, boiler, everywhere, until it is given adiabatic. Even if it is open system, closed system, you can use it anywhere. H1 minus okay, VDP, you know, integration VDP work, you know, H1 plus half V1 square plus GZ1 plus Q is equal to H2 plus half V2 square plus GZ2 plus W external. W external means all the works that are given, like work done on the any system, like except flow, that flow work, because H1 contains flow work already, that's why. So there is nothing absolutely new, not nothing absolutely which is new. So use W is equal to minus PDP anywhere, use it, no one going to stop you. Now the important is free expansion. What is free expansion? So this is free expansion. Here, vacuum, insulated. So Q is equal to 0 because insulated and no heat will be there. Q is equal to 0. W is equal to 0 because no work will be done to, if we remove this line, no work will be done for gas to expand, as no work is done against the vacuum. So delta is equal to 0. For ideal gas, delta is equal to 0 means T1 is equal to T2. Now use P1, V1, PV is equal to MRT. You can see that volume is increasing. V2 is equal to 2 times V1. So P2 is equal to half times of P1. So for free expansion, work is equal to 0, heat is equal to 0, temperature remains constant. This is irreversible process, pressure decreases. All these things are important. Now the next important thing is mixing chamber. In mixing chamber, this is the mixing chamber, nothing. Q will be 0 because adiabatic. Mixing chamber is considered adiabatic. No heat can flow through, no heat can, it's nothing. M1H1 plus M2H2 is equal to M3H3 because stream 1, stream 2, stream 3. So this means mass is conserved. M1 plus M2 is equal to M3 and M1H1 plus M2H2 is equal to M3H3. You can use H3 is equal to CpT3, H1 is equal to CpT1 and H2 is equal to CpT2. For air, Cp will remain constant. So from here you can find temperature and everything. Just this. So mixing chamber, grade 2021. Solve that question. You will know everything. Throttling, you know, H1 is equal to H2. For throttling, for ideal gas, temperature remains constant. For real gases, temperature may increase or decrease in throttling process. And जूल कोफिशिएंट के उल्टा चलता है टेम्परेचर. इफ जूल कोफिशिएंट डिक्रीजेस और इज नेगेटिव, टेम्परेचर इंक्रीजेस. जूल कोफिशिएंट पॉजिटिव, टेम्परेचर डिक्रीजेस. उल्टा चलता है जूल कोफिशिएंट. सो नथिंग, दिस इज द क्वेश्चन. Nothing. Get 2021. M1H1 plus M2H2 is equal to M3H3. You will for finding Cp for air is constant. Cold air, fresh air, no matter. Cp does not depend on mass. It is an intensive property, so Cp will remain constant. Only you have to find T3. You can find T3 by M1H1 plus M2H2 is equal to M3H3. And H1 is equal to CpT1 plus CpT2 is equal to CpT3. You find T3. Find here you can also say mCp into 24 degree Celsius. और यहाँ पे so difference between this gives the heat. मतलब यहाँ से cold air आएगी, यहाँ से hot air जाएगी, तो यहाँ से जितना heat लेगी वो ये लेगी. But this is the there in this 2021 question. So open system is fully done. Do nothing, just absolutely nothing. Just some questions are there, just do them. not even a YouTube video or not even any practice is needed. The questions that are necessary are absolutely done, and I have everything in my mind that comes in the exam. So no worries for open system, no worries thermodynamics here, overs.